In my previous role, I did spend a lot of time dealing with software stacks and managing them on an HPC environment and some other systems that you probably installed.
Probably my fault.
Yeah, so
Yeah.
you were to blame for this.
It's almost certainly my fault.
Yeah, so when we talk with like other customers in the cloud with software management, I mean it's largely a solved problem. Whether they're running stuff in Lambda or containers or it's pretty straightforward. But HPC software stacks are a different beast.
Just a little.
Just a little. When we're talking about very, very big differences between what compiler flags, even what compiler versions you're working with, what flavor of MPI. I think my previous job, we had to maintain like 6 or 7 different versions just of GROMACS. And then all of the combinatorial differences after that. So how do we, just to sort of put a picture to to all of this, this is Wharf.
This is one of the simpler ones, let me point out.
It is. Wharf is relatively simple to build.
Wharf has only got like 50 dependencies.
Only, yeah. So I want to talk through some of the different options that you have for doing software management on AWS, and go through some of the pros and cons and sort of what my opinionated take on how to use them. So the first one I'm going to kind of call build systems. So this is going to be sort of very very traditional sort of infrastructure and configuration management tools, Puppet, Ansible, that kind of thing. This is something that people are probably familiar with because they'll use this in CI/CD pipelines on in an on-prem environment. This is nice because if you're using this, it's very easy to duplicate what you have on the cloud. Okay, because we've got build systems for this as well. This probably isn't ideal for HPC applications because you're going to have to sort of condense all of that Wharf dependency tree that we saw. You're going to have to condense all of that into like a single Ansible playbook, a single configuration approach, and it's going to be messy. Where you want to probably be using this is, let's say you're spinning up an instance in parallel cluster, and you want to sort of set some standard security options, or you install sort of a general set of packages for users, stuff that you don't necessarily, stuff that isn't going to be very customized. You could drop this into like an EC2 image build pipeline. You publish that image, it gets used by your compute nodes when they spin up, and it's just there. The benefit with that is it doesn't take time to configure and install that once that instance is up.
Yeah.
And that also integrates well with the CI/CD pipeline. So these are good, like I said, for sort of that golden image that your internal IT and security want to approve, that you can then build upon for those HPC applications. The other thing, and I know this isn't like a build system, but it is important to talk about file systems in the context of application management. You probably don't want to build all of your applications into a single image. That image is going to be massive. So this is where something like a shared file system comes in. Most of the time we point people toward EFS in the cloud, Elastic File System. It's our managed NFS share.
This is where something like OpenZFS is really cool, because OpenZFS, ZFS is used regularly as a home directory file system. It's a perfect use case for that. Works really well in scenarios where you're doing a lot of parallel builds. And one of the nice things about OpenZFS is you can snapshot file systems with a click of a mouse, the click of a button in the console. You can snapshot, you can fork file systems. It is actually a super cool file system.
Yeah. So another way that we often see people installing software is like sort of user install methods. So post install scripts.
Yeah.
This is really good for those sort of really customized things that the user wants to do, changing something. But for managing large software stacks, don't do this. Okay, this is going to be messy. This really should be sort of that kind of last mile of whatever the user needs to set up. This is nice also. This is going to be a lot quicker to like test and deploy versus a CI/CD pipeline. But once this is set, if you aren't really going to change what you're installing, put it into like an EC2 image build, into a CI/CD pipeline, so that it's tracked and managed. Because this is the other thing, in terms of reproducibility,
Yeah.
this is going to be very hard to track.
People's gum together shell scripts are not reproduced.
Yeah,
That is not-
you mean not everyone puts them all into a Git repo and checks them and like they should?
Perhaps not. Okay, package manager.
Yeah, so-
this is the way better approach.
Yeah, way better approach. Package manager. So, things like SPAC and Easy Build, you're going to get HPC optimized builds. We've got things like binary caches so that you don't even have to compile software. It's already been done. These have massive user communities. I mean, we had SPAC BOFs, SPAC
IC
workshops,
this week.
tutorials. I mean,
Totally. And look, if the link will be up here in a second. Just wait for it there, folks. We wrote a whole blog about how you can drop a single reference to a shell script, to a post-install script for your parallel cluster into your config, so that you're going to have parallel cluster install SPAC for you at build time when it's constructing the cluster. And when you log into your cluster, you can just go SPAC install Wharf, SPAC install GrowMax, SPAC install OpenFOAM, whatever it happens to be that you want to install, and it just does it. And in fact, going out of the binary cache version of that, because it builds a private binary cache for you, it takes 1 second to install GrowMax.
that's amazing.
1 second.
So, sort of to summarize all this, if for anything that you need to do sort of that golden image approach and, set security configurations or some, base packages that everyone's going to use, or to handle like OS upgrades, put this in some sort of CI/CD pipeline with, like EC2 image builder. Do that. It's best practice. It's going to be repeatable. A little bit of setup time, but it pays dividends in the long run. If you're going to have to manage some sort of large software stack, lots of dependencies, like most HPC software stacks, use a package manager and put it on some kind of shared file system. And then finally, if all else fails, and you do need to do some little tweaking, and the user is going to sort of own this themselves, post-install scripts are a way to do this.
If you're enjoying these videos, please give us a like and consider subscribing to the channel so that we can keep making more to help you understand how the cloud works and to show you new ways to help all the scientists and engineers around you who use HPC every day to do amazing things. It's what gets us motivated as well. See you next time.